let us see some questions which are important and concept oriented, which suits for this type of the carboxylic acid questionnaire, and we expect 1 or 2 questions this year are going to come from this expected questions. So let us see the question number 1. In the reaction sequence, that is, an acetaldehyde is given treated with HCN in basic medium. So a compound A is formed which are hydrolyzed with the acidic medium H2O in presence of H plus, means acidic medium hydrolysis. The product formed we are going to identify. The product will be, the first answer is hydroxyacetic acid. It is absolutely right answer. But you see the answer here, B is the answer is also there. It is also same acid, that is the configuration is slightly opposite. So in the C we have a mixture of this A and B, both are given. So if the answer is the D is the definitely hydroxyamide is given, wrong answer. If it is more than one answers are given, actually A, B, C will be the right answers. But if it is only one answer is right, means in acetaldehyde what is happening, we have a trigonal planar carbon is involved here. With reference to this plane, when cyanide minus is allowed to attack, it may attack from this side or from the back side of this one. So leading to give the 2 different types of the products. So one may be the OH that is from the right side, methyl group down, and the COOH up. This is one answer, and also you get the another answer which is a mirror image of this one, hydroxy may be this side. So first added HCN followed by the hydrolysis also we have done. During this hydrolysis the carboxylic acid is generated, otherwise it will be a cyanide added the hydroxy. Hydroxycyanide is hydrolyzed to become into hydroxy acids. So dextro and levo, both the compounds with reference to this plane, it's 50-50 chance is there, therefore you will get a racemic mixture is formed in this reaction. So the answer goes to the C answer is the right answer. A, B is also right, but out of A, B, C, C is the most correct, therefore one single answer means it goes to the answer goes to the C, therefore. Now let us see the question number 2. Which of the following reactions will give alpha hydroxy acid as a product? So the first answer is acetaldehyde with the sodium cyanide. A cyanide group is added on the carbonyl group followed by hydrolysis, that gives a alpha hydroxy acid. The second one is B is acetaldehyde with bromo, alpha bromo ester. This is known as actually Reformatsky reaction, in which alpha beta unsaturated acids will be the answer. That is the wrong answer. Answer C is a beta hydroxy compound with hydrolysis, you will get a beta hydroxy acid. So all of these is the wrong answer. So answer goes to the straight for first answer, that is acetaldehyde on reacting with the cyanide group followed by the hydrolysis. So cyanide is added here, O will become O minus, that is on hydrolysis you will get a carboxylic acid containing the OH group. So this is what he is asking, alpha hydroxy acid is prepared from the acetaldehyde, so therefore answer goes to the A. First answer is the A answer is the right one. So let us go to the question number 3. In the given reaction, calcium salts of the following, a dicarboxylic acid is given and it is treated with only heating. This is called pyrolysis. Pyrolysis of the calcium salts undergoes a reaction. We have a conceptual reaction here. For example, if we have how many carbons we have taken? 5 plus 2, 7. So 7 carboxylic acid, 7 carbons containing carboxylic acid in the form of a calcium salt. So that is a calcium plus 2 is taken and heated. This is what the reaction is asking, in which what happens, a calcium carbonate will be left over in the flask, and this compound becomes into a ketone. A 6-membered ring with a ketone, that is cyclohexanone will be the answer. So the answer goes to the therefore cyclic ketone, that is the answer C is the right answer. However, the reaction has some concept here. So the option A is monobasic acid. So acids will give the ketones. Acid anhydride, this has also got some validity here. For example, if a 5-membered acid is taken, 5-membered means this is called adipic acid. Calcium adipate, if it is taken heated, you are supposed to get 1 calcium carbonate and the 4 carbon ketone, right? But the 4 carbon ketone is unstable. Instead, the 5 carbon anhydride is formed. So in the case of 5 carbon, anhydride formation is the right answer in fact. But we have taken a 7 carbon one. So 7 carbon 1 will give the 6 carbon ketone. 6 carbon 1 dioic acid will give the 5 carbon ketone. 5 carbon calcium salt will not give the 4 carbon because of instability, it gives the anhydride. So the cyclic this is acid anhydride B is also right answer in the case of calcium adipate, calcium glutarate this is. So adipic acid onwards we get this type of the calcium salts will give the ketones, that is a cyclic ketone is the answer. C is the right answer. A slightly depth containing question it is actually. In the dicarboxylic acid, it so happens on pyrolysis reaction, 1 calcium carbonate is deleted and you are going to get a 1 carbon less cyclic ketones. So given compound is a 7 carbon, therefore you will get a 6 carbon ketone, right. So let's go for the question number 4. Sodium bicarbonate reacts with the salicylic acid to form. So any carboxylic acid generally with bicarbonate liberate the carbon dioxide. So salicylic acid also contains the carboxylic acid and the OH. So sodium bicarbonate is a base. So phenol is a weak acid, therefore it won't react, but the carboxylic acid is going to react and forms into the sodium salt. The bicarbonate will form a sodium salt of the carboxylic acid. So this is what the basic skeleton reaction. Now he gives the answers when salicylic acid is treated with the sodium bicarbonate. What answer? The first answer is a sodium with benzene, wow, that is a sodium salt of phenol, the CO2 gone, so that is wrong answer. So in the B answer, sodium salt is rare, that's the right answer. In the C, it is the sodium phenol is also converted into sodium salt, that is wrong. Phenol will not react with the sodium bicarbonate, only carboxylic acid, strong acids are enough that react with the sodium bicarbonate and liberate the carbon dioxide. That carbon dioxide not comes from the acid, it is from the bicarbonate. Sodium bicarbonate will give this carbon dioxide. This from this carbonate you get a carbon dioxide. The carbon dioxide comes with a bubbles coming, and it is also known as what? Effervescence. A bubbles giving a reaction it is called effervescence. All carboxylic acids will liberate this type of the carbon dioxide. So the option C and the D also wrong. So the option B is the right answer. Answer B is the right answer. Let's go for the question number 5. A salicylic acid is heated up to 200 degrees. Salicylic acid is nothing but a phenol containing a COOH at ortho position. Orthohydroxybenzoic acid or orthocarboxylic, the phenol is known as what? Salicylic acid. This is heated at 200 degrees without anything. So generally what happens when you heat it, carboxylic acids undergo decarboxylation, you will get the phenol. But this phenol in turn may react. If a phenol is given as an option, we can go for that option, but the options are given phenyl salicylate, aspirin, that is acetyl salicylate is wrong, benzene, both removing is not possible, benzoic acid is also partly correct, but OH removal and COOH retaining is wrong. So therefore benzoic acid is also wrong. Phenyl salicylate means actually this on heating what happens, a decarboxylation takes place, a phenol is formed. This phenol is reacting with this benzoic acid group and an ester is formed. That means O with a phenyl. Phenyl salicylate is formed, this is called salol. Is also a wonderful medicine in the analgesic type of the drug, so which may be prepared by this particular reaction. Heating the salicylic acid alone, it partly gives this one, and this again undergoes esterification with this one. So two molecules are participating in this reaction. If a alone phenol is there, we too can go for this option, that phenol, but phenol is not given. So, therefore, phenyl salicylate, answer A is the right answer. So, answer A is the right answer. Let us go for the question number 6. In sixth question, which of the following acids give faster esterification with the given methyl alcohol? Alcohol is given standard, but the acids are given in different carboxylic acids. A carboxylic acid reacts with this alcohol and gives the ester formation. In this, during the ester formation, the alcohol, if it is the 1 degree, better reacted over the 2 degree over the 3 degree. So, therefore, the given acids, check it that the first one is a secondary carboxylic acid, the B option is a primary carboxylic acid, option C and option D are the tertiary carboxylic acids. So, therefore, option B will be the right answer. Answer B, which is a primary carboxylic acid, undergoes a faster esterification. Now, let us go for the question number 7. The question is in the given reaction, a reaction is given with acetic acid, first treated with bromine and phosphorus. Acetic acid is treated with the bromine and phosphorus, first reaction, followed by treated with the sodium cyanide, then finally treated with the hydrolysis. In acidic medium. So, in this during the course of this reaction, first what happens, acetic acid will become into alpha bromo acetic acid, a bromine enters here. So, this compound on treatment with the sodium cyanide, second step, a cyanide is entered in the place of bromine. It is a replacement reaction, nucleophilic substitution reaction. This cyanide will have a triple bond, will undergo hydrolysis reaction, will become a carboxylic acid. So, therefore, final answer will be that 2 carboxylic acids are coming. Original carboxylic acid, in addition to that, halogenated, converts into cyanide and hydrolyzes to give the acid. So, therefore, the answer X is asked here. X will be the option A is a malonic acid, that is the right answer. Option B is the 4-carbon dioic acid, that is succinic acid, wrong. Answer C is the succinic anhydride, there is no dehydrating agent to give this anhydride. Option D is also wrong answer, which is also a 4-membered anhydride is absolutely wrong. Formation itself is highly not possible. So, the option A is the right answer. A is the right answer. So, let us go for the question number 8. The question goes like, which optically active compound on reduction with lithium aluminum hydride will give optically inactive compound? So, originally the compound should be a optically active. Optically active means what? A B, C, D containing a chiral carbon containing compound. After reaction, it should become some identical groups should be formed. That means, if A is there, okay, let us say the B is converted into D and or B is converted into A already, which is D is there, the B is converted into D. So, the identical groups are formed. Such type of the relation should be formed in the reaction. So, he says original compound is optically active, on reduction with lithium aluminum hydride it gives optically inactive compound. So, the answer must be inactive compound which is originally active. So, the acetic acid, if you take this particular compound, that is a methoxy contain acetic acid, the acetic acid with lithium aluminum hydride will give the alcohol, but that alcohol is not there. So, answer A is wrong. Answer B is we have a carboxylic acid becomes a ethyl alcohol, but that such a type of ethyl alcohol is not there. So, in the option C we have a optically active. In the option C we have a optically active COOH and CH2OH, and there is a hydrogen. So, this is an optically active. Option C, if you carefully observe, this is the optically active compound. On reduction with lithium aluminum hydride, this COOH converts into a group which is already there. So, therefore, it will become a optically inactive compound. a CH2OH is generated out of this lithium aluminum hydride. So already a CH2OH is there. So this will become a optically inactive acid. This is the right answer. Then lastly the other one also, that won't be the inactive acid. So the answer option C is the right answer. So the concept here, original compound is optically active. After a reaction, one of this ABCD is converted into a group which is already there, like for example as I have shown here, A, B, C, D are there. B, if it is converted into a D, so which is already there. So like that here also a COOH, CH2OH different groups, but COOH when it is reduced to CH2OH which is already there, so therefore it will become optically inactive. That is the concept involved in this reaction. Question number 9. Ketones can be formed from acid chlorides on reduction with. Acid chlorides actually RCOCl 2. When you add RMGX, we have one reaction. RMGX reacts twice reacts. You will get a RCO minus and R is generated. The O minus when comes back, the Cl will be goes out. You will get a ketone. So we think this must be the reaction, but the ketones once again react with the RMGX, and what you will get finally is a tertiary alcohol salts, which are acidification. You will get the finally tertiary 3-degree alcohols, isn't it? That's not we want. We want to stop the reaction at here. So therefore RMGX you treat it with the cadmium compounds. Cadmium chloride, if you add, this converts into the dialkyl the cadmium. Dialkyl cadmium is a less reactive compound, only one step reaction takes place and stops at the ketone further reaction. That is, even the ketones add with the dialkyl cadmium, they won't react. So the reaction can be stopped. So therefore concept here is ketones can be formed from acid chlorides on reaction with R2CD is the right answer. And RMGX excess if you add, as I said, tertiary compounds are formed. Lithium aluminum hydrides will give the 1-degree alcohols are formed. RSH, this is an alcohol also, esterification takes place with the thioesters are formed. So the right answer goes to the answer A. Answer A will give the ketones are formed. When R2CD is added, this R dash will enter, you will get RCOR. The reaction stops at the level of the ketones, further reaction will not take place. That is the concept here. So let's go for the question number 10. The question goes like, reducing property of formic acid is due to the presence of. What is reducing property? Actually, an RCHO is an aldehyde function, isn't it? Generally we add a tolerance reagent. A tolerance reagent. A reagent contains what? Ag silver nitrate, Ad plus will be there. So this compound is oxidized to carboxylic acid. This is oxidized. So the silver is reduced to silver metal 0. So this compound is reducing the silver. So therefore this compound is called what? It is undergoing oxidation, but it is called as a reducing agent. What is the tolerance reagent? Which is an oxidizing agent. So the aldehydes will have originally reducing property, but unfortunately there is a carboxylic acid. This is having actually carboxylic acid function, but if you see this side we have an aldehyde. So if you add tolerance reagent, what is happening? That is ammonical silver nitrate. This side aldehyde function will become into the carboxylic acid. That side already acid is there, so that is a H2CO3 formed, that is carbonic acid is formed. So therefore the formic acid has an aldehyde function, so that's why it is having this reducing property. So the question is now, reducing property formic acid is due to the presence of not the OH. Answer is B, aldehyde is right, and carboxylic acid is a acidic property. All of this is also wrong, so the answer goes to the only B. So the only the formic acid has got this type of the unusual behavior. It has the acidic property as well as the aldehyde nature, that is the reducing property is also there. Let's go to the question number 11. Which of the following compounds will give acetic acid with permanganate in basic medium? So it is an oxidation reaction. Perhaps the different compounds are given, must be, and they are asked for the oxidation reaction. So you get acetaldehyde and oxidation gives the acetic acid. Even alkene containing this type also undergoes just like oxidative ozonolysis or acidified permanganate or alkaline permanganate with heating. It cuts and you will get the 2 moles of acetic acid. Alkynes also will undergo this type of the cut and you will get the 2 moles of acetic acid. Therefore, all A, B, C is the right answer. So, therefore, answer goes to the single answer, means D is the right answer. So, answer D is the right answer. So, let us go to the 12th question. Which of the following compounds will not give benzoic acid with permanganate in alkaline medium? Benzoic acid actually formed when an alkyl group like methyl, okay, this hydrogen either in the basic medium or acidic medium in KMnO4. In basic medium, the H is replaced by the OH. In acidic medium, nascent oxygen will be there. Insert and you will get OH. Afterwards, one more OH, 2 OH eliminate aldehyde. Next, it will become acid. So, toluene will become into the acid, right? And the next concept is if you have a long chain of the compound like this, let us say 6 carbons are there or 5 carbons are there. So, it is not all the carbons, but the first carbon holding the hydrogen which is responsible and shows the hyperconjugation starts and oxidation, it will become hydroxy. Then one more OH, 2 OHs eliminate and you will get the a carbonyl group is a double bond is formed. Then this hydrogen start oxidation, they give this one, and finally it breaks, and what you will get is one of the component will be the benzoic acid. This is all happens when there is a carbon containing the oxidizable hydrogen, that is a hyperconjugation showing hydrogen is there. So, now let us see the answer 1. Answer 1 has a benzoic acid carbon attached which has all 3 the carbons, isn't it? So, therefore, that cannot be oxidized, that has no hyperconjugable hydrogen. B has 1 hydrogen, so that starts oxidation. C also has 1 hydrogen and already partly oxidized. Even D has 1 hydrogen oxidizable, therefore, B, C, D undergoes oxidation will give the benzoic acid except A. So, therefore, answer is A. So, the A carbon, that is option A, has a structure like this. The carbon has all substitutions. However, here we have a OH, but on the carbon which is attached to the benzene is not having any hyperconjugable hydrogen. Therefore, oxidation will not take place on the carbon. Therefore, subsequently, you won't get the benzoic acid as the main product. Therefore, answer A will be the right answer. 13th question. The acetic acid can be used for the preparation of. So, starting with acetic acid, which of the following compounds can be prepared is the question. 3, 4 answers are there, but which answer comes? Well, let us say ethane. If you want to prepare a 2 carbon compound with the CH3, it can be prepared, make a sodium salt, and even with a HI phosphorus reduction will give ethane, or make a sodium salt and do the Kolbe electrolysis, ethane can be prepared. Okay, right. And he want to prepare a methane. Methane also can be prepared, make a sodium salt and go for the soda lime decarboxylation, you will get the methane is the results. So, the methane also can be prepared. And acetone he want to prepare, it is also possible because make a calcium salt of acetic acid. Acetic acid is treated with the calcium hydroxide, you will get a calcium salt, pyrolysis will make the calcium carbonate back and you will get acetone. So, all the A, B, C are the right answer. So, therefore, option D will be the right answer. So, therefore, answer goes to the D is the right answer. Okay. So, it can be methane, it can be ethane, it can be acetone also, all 3 can be prepared, therefore, all are 3 correct. So, therefore, answer goes to the D answer. So, let us go for the 14th question. Consider the given reaction, that is a silver salt of carboxylic acid is given, treated with bromine and heated. The CO2 will be lost and silver bromide is removed, 1 bromine comes here, alkyl bromide is formed. This is known as a decarboxylation cum bromination. It is a known reaction called Hunts-Decker reaction. So, which of the following acids will give the maximum yield that is alkyl bromide in the above reaction. The process goes through the primary compounds, that is it goes through the carbanion formation actually mechanism. So through the carbanion, that is the primary compounds will bear the carbanion easily, tertiary the carbanion forming will be the difficult. So therefore primary carboxylic acids undergo decarboxylation reaction fast. So therefore first one is a secondary carboxylic acid, B option is a primary carboxylic acid, C is a tertiary carboxylic, all give the same yield is wrong. So the B is the right answer. That is 1 degree alkyl halides undergo faster reaction over 2 degree, over 3 degree. So this is the, based on that we have decided answer B is the primary alkyl, that is carboxylic acid, which it turns up into a silver salt and undergoes into reaction. Decarboxylation is easy in the 1 degree carboxylic acids. Let us go to the 15th question. In the reaction sequence, a propanoic acid is treated with the hydrogen peroxide. Hydrogen peroxide, and the X compound is formed, that is on heating gives the Y compound. The question is what is Y? So in this reaction what is happening? The hydrogen peroxide goes to the beta carbon and that undergoes a decarboxylation. So the beta carbon undergoes a hydroxylation. This undergoes a decarboxylation. So the compound becomes into a Y is a must be an unsaturated carboxylic acid. So that is the right answer. So the option A is only just hydroxy acid, wrong. Answer B is the unsaturated acid, that is right answer. Answer C is the beta hydroxy, that is actually formed in the as the X. Then the D lactic acid, that is also a lactide is also a wrong, because the acid is not there, how the acid and the alcohol reacting will not take place. If it is a then next carbon gamma onwards, the internal esterification takes place and you will get lactide, but here in this case lactide formation is not possible. Beta hydroxy undergoes elimination. There is a concept here, a carboxylic acid containing, let us say, different OHs are there, all OHs are there, alpha, beta, gamma, delta and so on. Alpha hydroxy undergoes a lactide formation, beta undergoes a dehydration, gamma onwards undergoes a lactone formation, intermolecular. This gamma alpha makes a, if alpha OH is there, 2 carboxylic acids will react like this. This is hydroxy, carboxylic. Another compound, a hydroxy group and a carboxylic acid. This is called a lactide formation. Alpha hydroxy acids on heating becomes lactides. Beta hydroxy compounds, if OH is beta, alpha hydrogen shows hyperconjugation, therefore elimination takes place and we will get alpha beta unsaturated acid. If gamma onwards is there, gamma OH if it is there like this, COOH. So alpha, beta, gamma. If gamma OH is there, this and this will react, a cyclic ester is formed. That is called what? Lactone. This is called what? Lactide. So lactide is formed through the alpha hydroxy acid, but X is a beta hydroxy acid, therefore you will get a unsaturated acid, that is alpha beta unsaturated acid. That is the concept here. So the answer will be the B. So let's go and discuss some questions from the IEEE. The recent question, that is a 2011 question. That is the first question. The strongest acid among the following compounds. So he wants the acid which has got the more acidity containing compound. Options are given as acetic acid is the first option, formic acid is second option. If A and B is there, definitely B is the strong acid. But compound C is having a alkyl group, but the chloride is very close to the COH. It shows the stronger minus I effect, must be the strong acid. So answer D is also having a chlorine but far away, so therefore this effect will be less. So therefore net answer will be the chlorine containing a carboxylic acid closer to the carboxylic acid, though the 3 carbons are there, but the chlorine is very close. So therefore the carboxylic acid having the minus I effect will be the stronger acid. So the answer goes to the third answer. Therefore a carboxylic acid having a closer minus I will be the stronger acid. Let's go to the question number 2, a descriptive question. Question number 2 appeared in the 2009 recently. A liquid was mixed with ethanol and a drop of concentrated sulfuric acid added, and the compound with a fruity smell was formed. The liquid is. So he has taken ethyl alcohol, some X compound he has taken and added ethyl alcohol in presence of a concentrated sulfuric acid. H2SO4 is the catalyst he is using, and then he got a compound which is having a fruity odor. This smell containing compound giving is a symptom for the ester. RCOOR type of functional group containing compounds are fruity odor containing compounds. So therefore the ester must be formed. What he has taken must be an acid. So let us go for the options here. One is the methanol, that's wrong. Formaldehyde, wrong. So C option, that is acetone, wrong. The option D, acetic acid, is the right answer. So if I take acetic acid here, you will get an ester called ethyl acetate is formed. Ethyl acetate happens to be an ester and gives a beautiful good smell. So therefore the answer is the D. Answer D is the right answer. Now let's go for the question number 3. The third question, he has taken a compound like an alkene containing attached to the COOH. This is called propenoic acid, or commercially called acrylic acid actually. This acrylic acid is reduced with lithium aluminum hydride. The compound obtained will be. So this lithium aluminum hydride is no doubt it is a good reducing agent, but it supplies the H minus, attacks on the carbonyl group, not on the alkenes. Alkenes also rich with electron, therefore H minus will attack on the carbonyl group of the acid. So the H minus will attack here, O minus. When O minus comes, OH will go, aldehyde comes. Again, once again H adds, you will get the alcohol function. So the compound is finally converted into the, so the alkene function will be retained as it is, but it will become into the alcohol. This is the answer in this reaction. So let us see the options here. The first one is the COOH is as it is, but the alkene is reduced, that is wrong. The second one is ene is protected, alcohol is formed, that is the right answer. And the option C is the alkene, alcohol and some other compound is joined, and alcohol is formed, that is wrong. And the option D is also phenyl group has joined with this one. So then nowhere the phenyl coming chance here. So therefore option D is also wrong. So the answer goes to the B answer is the right answer. That is the acryl alcohol is the right answer. So let's go for the question number 4. The correct order of the increasing acid strength of the compounds. So 4 different compounds are given, and increasing order means the first acid will be the weak acid, then little more stronger, then little more stronger. The increasing order you have to arrange. Now the options given is acetic acid he has given, methoxy acetic acid. Methoxy group is a minus I effect, it cannot show plus M effect here. So methoxy is a minus I, therefore slightly stronger one. And trifluoroacetic acid, option C is trifluoroacetic acid. This has got 3 minus I groups, so therefore strongest acid. Option D is having an acetic acid with 2 methyls, that is the weakest acid here. So therefore option D goes to the weakest, starts with the D, therefore our answer should start with the D, end with the C. So therefore there is only one answer starting with the D. Elimination technique you may apply here. So the D, A, B, C, right answer, that is the answer goes to the third option, that is the C is the right answer. So as I said, the carboxylic acids we have a general explanation. Any group which donates the acidity is decreased. Any group which withdraw the electron density through the minus I effect or through the minus hyperconjugation and so on, the increases the acidity. So we have a option C has got a 3 fluorines containing acetic acid. This is one of the strongest acid of the different carboxylic acid. So this comes in the increasing order. He wants to mean it should be at the end. So the option C should be at the end. So therefore here the option final answer will be the C will be the right answer. Therefore answer C is the right answer, in which this trifluoroacetic acid is arranged at the end and the dimethyl acetic acid at the first, and in between that acetic acid and the methoxyacetic acid. So the answer C is the right answer. So let's go for the question number 5. Appeared in the AEEE in the 2005. The question says that among the following acids, which has the lowest pKa? As we see that the Ka value, if highest, the acid will be the stronger acid, but pKa value lowest is the strongest acid. So we have to search for the question which has got the lowest, means strong acid. As we have seen in the carboxylic acid, any donating group is there, acidity will be decreased, as no donating group or withdrawing groups will be the stronger acids. So therefore if the options, if you see, the option A is propanoic acid, option B is that is a 2-methyl propanoic acid, option C is only formic acid, option D is the acetic acid. So in A, B, D we have some donating groups to the acetic acid, whereas in the option C we have only formic acid, no donating groups. Formic acid, when compared with all the acids which have some donating groups through the plus I groups, must be the weak acid. They are all weak acids. This is when compared with the formic acid. All such acids which have taken in the option A, B, D comes under this category, where plus I effect decreases the acidity. So formic acid will become the strong acid. However, in fact, if you have any withdrawing group like chloroformic acid, would have become a strongest acid. But the question is here, formic acid versus the other alkylated, the formic acid. So A, B, D wrong answers. So answer goes to the option C. So let's go to the question number 6 here. Sodium ethoxide has reacted with ethanoyl chloride. Ethanoyl chloride means acetic acid, acetyl chloride, which is treated with the sodium ethoxide. So the ethoxy group will replace the Cl. It is a nucleophilic substitution at acyl carbon and will give a ester formation, CH3CO, OCH2, CH3. Ethyl ethanoate or ethyl acetate is formed. This is the reaction which we have involved. The compound that is produced in the above reaction is, he is asking. So the first option is diethyl ether. Diethyl ether means two ethers, ethyl carbons attached with this one, that's wrong. To butanone, a ketone is formed, that is also wrong. To butanone is nothing but isn't it, a ketone. So ethyl chloride is a saturated ethyl with the chlorine. So all these options are wrong options. So the option D is ethyl ethanoate or ethyl acetate is the right answer. So therefore answer goes to the D is the right answer.